All right, so my name is Heather West. I've been with Walters & Wolff for a little over 15 years, and today I'm going to talk to you about extrusions. A lot of you may or may not have been to an extruder, so I thought I'd show a little video on some of the different things happening in the extrusion world while at the extruder. This is a die. And where he just pulled it from was what they call a hot box. Before the die can go to press, it needs to get loaded into the hot box and heated up to a specific temperature. That way the heated up billet can easily flow through the die. These are billets, or you'll hear them called logs. That is what's getting fed into the press. The logs can be at different diameters depending upon the press size. And before the billet goes into the press, it does get heated up to a high temperature, and then will get pushed through the die. As the material is getting pushed through the die, it's coming out into a quench, which can either be water or air, forced air. Typically, you'll see a lot of presses have forced air because the water can be messy. This is critical because you want to cool down the extrusion rapidly so that the properties set to give it its strength. And this can be an issue, especially when you're talking about structural alloys. If it does not get cooled or quenched fast enough, it will not meet the properties. After it goes through the quench process, an arm comes and grabs the material and it pulls it down the table, just helping facilitate it. Then it'll go into a set of stretchers, which basically snaps the extrusion and sets the properties. And that's what gives it its final shape. Then they will typically give it a rough cut to length. There is a slight variance in that tolerance. And then it'll go into an aging oven where it is artificially aged. And that's what brings it up to the temper. Typically we have T5 or T6 with our architectural shapes. And then from the aging oven, it'll either go to fabrication or it'll go to the paint line. And then it'll get packed to come to us. So basically in this presentation, it's focused on the process starting with the die package and ending with QC out in the shop. This presentation is kind of lengthy, so at the end of each section, I will see if anybody has questions. And if for some reason you don't have a question at that time, but one comes up later, if you want to use the chat on the Zoom to send those questions over, I'll review at the end of the presentation. So since we're a custom design glazing company, most of our projects require new profiles for extrusions. The first step in the process is the die package and the die drawing process. Jumpstart provides a set of profile drawings that contain all of the new and existing parts to be sent to the customer for approval. When this is happening, a preliminary set of die drawings is being sent to the extruder to review and comment. Any extruder requested changes will be incorporated once the approved profile drawings are received back from the customer. Jumpstart will then update and send a new die package to the PM and purchasing. And while the drawing process is going on, we're keeping track of when the die package was sent to the extruder and when it gets returned, when the dry drawings get returned, when they get approved. If there is a revision, we track when it goes back to the extruder for revision and when it gets returned back to us. And then once the die drawing process is complete, a final die print is sent, and that's what gets processed and posted on the portal, and part drawings get generated for the drafting and takeoff teams. Sorry. Here's an example of a die package. A die package, like I said, contains all of the new shapes and details for the project. Purchasing will release the new die package to the selected extruder once all the project information and warranty forms are filled out by the PM, and we'll go through that a little bit later. And a die quote will also be requested at that time. Once all the die drawings are approved, purchasing will release a purchase order to the extruder. And we'll also request first article samples. Standard first article samples are 3 each at 4 feet long in mill finish. And if there are new assemblies, which are 2 separate individual dies that are assembled together using a thermal brake, these will be ordered in 12-foot lengths. And the cost for the samples and assemblies vary by extruder. And if any of the new dies are going to be used on a visual or performance mock-up, we will not request the standard first article samples. We'll extrude the material required for the mock-ups and then check our samples from that. It helps saving some time and money in the process. Once the first article samples are received, similar pieces are cut for, or I'm sorry, smaller pieces are cut for jump start to approve from. They're typically 6 inches long. The samples are checked for fit with the mating parts and critical tolerances. Once all of the new dies for a project are checked, Jumpstart provides purchasing with the approval information, and then purchasing releases the sample approvals to the vendor. And that way, when the vendor has the sample approvals, they're able to release the production order for processing. It's important to know that once the dies are built, any changes to the profile will result in a revision to the existing die or may require a new die, and there is a cost associated with those changes. I already showed you an example of a die package, but to go into a little bit more detail, sometimes you'll hear dies called out as being solid. This is a solid profile. You may hear the word it's a hollow. Hollow dies are a little bit more complicated and more expensive. Any part of the die that forms a tube is considered a hollow. And then next we have assemblies. Assemblies consist of 2 individual dies, as you'll see here, and then they're joined together by what we call a strut or a thermal improvement. And initially this assembly is 2 individual dies. We call the front part or the exterior part of the assembly the A part, and then we call the interior portion the B part. So there's really 2 individual dies that make up that one assembly. So when the die package gets released to the PM and purchasing will send over a project scope sheet and warranty forms to be filled out. This information is required before the die package will get released to the extruder. On the scope sheet, we're looking for the quantity of new dies, the approximate pounds per new die. So going back to the die package, on this project here, they wrote down, the PM wrote down the approximate pounds required per die. It's not the lineal footage. If all you have is lineal footage, we can use that, but we'd like to have it in pounds. And if you have an assembly, will require either the total lineal footage of the assembled part or just what the pounds are for each of the new profiles. We also require the extruder results report. And what the extruder results report is a list of dies that are going to, or parts that are going to be used on the project. This is an example of the extruder results. If the part numbers are in red, that means that the dies are new to the project or that they at one point were existing but are no longer active at the extruder. That means we would have to rebuild that die, and there could be a cost associated with that. Also, getting this extruder results lets us know if any of the dies need revision. If the die number for a vendor is in blue, that means there's a note associated with that profile, and I need to go in and see what that note is for, if that die requires a revision or if there's something else that needs to be identified on that part. So it's important to get this list, that way we can send it to the vendor and make sure that all dies are active. We also need to know if there's going to be a mock-up on the project. That way we're not ordering first article samples as previously mentioned. Also what the project schedule is, the order date and due date for the metal order. That way the vendor can block out time in their production schedule for our order. Total pounds for the project, that gives the information needed to book metal. And then also the finished warranty form is provided so we can get warranty pre-approval for the finish on the project. And you fill out the project name, address, what types of components are being painted, what the end use is, and then the paint code and the number of years required. Or if it's an anodized project, you'll fill out what type of anodized finish is required. A few additional things to know about extrusions. So the thermal strut, as mentioned before, involves two separate extrusions and joins them through the use of an engineered structural polyamide plastic. Each extrusion will have features to receive the strut material. And as you can see on this profile on the right, there's little details in each extrusion that allows that strut to be inserted and then crimped into place. I did want to touch on some of the terminology. Sometimes you'll hear that a double dog bone is being used. That's when there's two struts holding the profile together. A hollow profile is this middle picture. that forms a tube, and then this would be a single dog bone strut. Alloys that we use are 6063, 6061, and 6005A. 6063 is typically used for cosmetic architectural applications, which is a majority of our extrusions. 6061 is used for structural applications, such as our hook lugs, mat clips, shear block clips. And 6005A is also used for structural applications. It has equivalent properties to 6061, but the makeup of it is a little bit easier for the extruders to push through their dies. It's not as rough on the dies as the 6061. We touched on tempers earlier. Typically, the extrusions are T5 or T6, and the temper represents the hardness of the metal in direct correlation to its strength. One thing I did not put on the slide is if you require your material to be stretch formed or bent, the alloy that needs to be provided to the stretch former will be a lower temper. That way it's more ductile for the stretcher to form the material. The ship tolerance, due to a high percentage of scrap that is produced by extruding aluminum through the dies, each vendor applies a ship tolerance. The customer pays for that extra material received. The ship tolerance varies by extruder and the quantity ordered per line item. And on the metal order spreadsheet, it notes what the ship tolerance is per vendor if you ever need to know that information. And after we receive the metal complete, the PO is updated with the actual received quantities. The next step to take place in the schedule for metal is typically the metal booking. The term metal booking or locking in metal means to secure a committed price via contract with the vendor. When the metal booking form complete to purchasing line is complete, or if it occurs in your schedule, review it with purchasing on the next steps. The reason to review this is sometimes the step has already been addressed during the die drawing process and with the project scope form being filled out. But it's always good to follow up again when it shows up in your schedule. Metal is typically not booked until we have received a contract for the project. If we want to lock in metal prior to a contract being received, there is a letter that the customer needs to sign acknowledging that there could be what the risks are for us to proceed with booking metal. Metal also might not be locked in due to what the market is doing. If the metal market is low and there's not a lot of variation, I may hold off on locking in a price just because there's an opportunity for the metal price to drop, and we want to take advantage of the best pricing we can get. And I review on a job-by-job basis whether we should lock in the metal or not. One important thing to note is once we lock in the price for metal, we bought that metal even if we don't use it. If the project schedule changes affecting the delivery of metal to our shop, or if the job cancels, there will be a cost associated with moving or canceling the contract. So if that happens, you need to review with purchasing immediately. The information required to book metal is total pounds for the project, the shop start date, shop duration, or number of weeks for fabrication. And the reason we need the shop start date and duration is because when we book metal, we are securing a forecasted number based upon the delivery of the extrusions to us. The price is not based upon the day, that current pricing. For jobs with 150,000 pounds or less, we typically book for the delivery to occur 2 weeks before the shop start date. For jobs over that amount, we will look at splitting up the order into multiple deliveries. That way we're not overburdening the shop with a lot of material coming in all at once. And if those deliveries occur over multiple months, then I need to base the booking on the number of pounds to deliver each month. So that's why I need to know what the duration of the job is in the shop. And I use my best educated guess and patterns from previous projects as to what that looks like. And whether we book metal or not, I'm working with the vendors on forecasting our projects and their production schedules in order to block press times and to also schedule time at their paint or anodizing lines. The two main extruders we currently work with are Western Extrusion and Hydro, with Western being our primary supplier. With Western, we are allotted approximately 160,000 pounds to ship to us on a weekly basis. There is approximately 40,000 pounds per truck, which means we could get equivalently 4 trucks a week. And since the pounds we can receive weekly is restricted, if your customer requests a schedule change, that will impact us. And if we end up moving the material to deliver to another week, we may already be committed to pounds on another project. So if a project schedule is changing, it's good to talk to us right away about that. Material lead times vary depending upon the vendor's capacity at time of order. In our schedules, we should be carrying about 12 to 14 weeks from the time of order. And for small onesie-twosie orders, you can see purchasing for current lead times, because lead times may actually be less than what we're carrying for an actual project order. Besides Western and Hydro, we also purchase miscellaneous angle, tube, channel bar from local suppliers such as Coastal Aluminum and SAF. And if you look at the wiki, I have a resource page for some of the miscellaneous items. There's a link to get to Coastal Aluminum site and to SAF site. Angles, bars, and channels and tubes do come in set lengths from these vendors. So you can use this page also to see what lengths are available in specific alloys. We also stock a few custom lengths for angles. The 4 angles we stock at 24 feet, and they are available in both a mill and anodyne finish. The tubes that we stock are more related to door header tubes, but these are also available for other purposes if needed. And if for some reason Coastal Aluminum or SAF does not carry the size you're looking for, I have links to both Hydro and Western standard shape catalogs, and we can see if they have a profile that fits your requirements. Other sources for extrusion on storefront systems are Arcadia and Conair. This material is typically purchased by the project managers, and PMs are to follow a separate procedure for procuring that type of system. So does anybody have any questions so far? before I dive into the metal orders.
When you say onesie twosie, do you mean like items that we had to reorder or just were missing or whatever, or do you mean like a small job?
No, I'm talking about things that got missed or, you know, replace some, or, you know, we misfabricated some material in our shop. Or let's say the customer hadn't decided yet at time of order what the SRT is, those types of orders. So I'm talking about typically somewhere maybe under maybe 5,000 to 10,000 pounds of material.
Okay.
Typically on the smaller side. A lot of it depends upon the vendor's capacity at the paint line, especially if it's painted. That usually drives what the lead time is. Or even if you have to get a part, if you have an assembly which requires the thermal break, that adds an additional week onto it. So there's a lot of variables for lead times at the vendors.
Okay.
So on the smaller line item orders, those are the ones that can typically get pushed through faster.
Got it. Thank you.
Yep. Anyone else?
Yes, I have a question that I put on the chat, and it's, when do we use T5 versus T6? Is there a general rule, or is that?
So if you ask Jumpstart, they may say something a little bit different than what I'm going to tell you, but my rule of thumb is if it's has no structural value at all, which I would consider like a cover, extended cover, maybe like the little trim piece at the top of our units, those would be a T5. Our verticals and horizontals are always a T6. So if it's the main body of your units, they're always going to be in T6.
Got it. Thank you.
Yep.
There was one more question on the chat.
Was there? For some reason, I can't pull up my Zoom. Can somebody ask me what that is?
Yeah, I just said that I noticed that the F clip was a new lumen die, but I know in the past we've done F clips, so I was just wondering if we made it into a die because lumen had a lot of them. And before, what we used to do was just modify a standard mat clip. Yeah,
on the mat clips, typically we would just modify the standard MIS, was it 5725 extrusion, into a left or right-handed mat clip. On lumen, there are a lot of mat clips, and they felt that it'd be cheaper to just have an F clip as an extrusion, but on typical jobs, we will not order that F clip because normally we only have a handful of mat clips on a given job. But on lumen, they have that's what they're typically using.
And do we have a fun fact in the chat?
Oh, that was me. Yeah. I just, when you mentioned strut, I Googled it, and I didn't know that you were going to go over it on the next slide.
Oh.
I was like, what the heck is a strut? And yeah, it's a plastic. And something interesting I found was, you know, they put it there for conductivity and stuff like that. And it said that aluminum is 533 times more conductive and more likely to, you know, pass heat than that little strip.
Nice. All right, well, I'm going to continue into the fun part, metal orders. So after the metal order is released from takeoff to the PM is to follow the metal order to purchasing Swiss. Here's a few items that tend to be overlooked by the PM and are worthy of further explanation. I will pull up a metal order. So make sure you fill out the metal price. At this point in time with you guys filling it out, it's not so much for me as it is for you to make sure that your metal order is going to be within your budget. If we did not book metal on your job, I would just default to the price that sales carried. Or you can check with purchasing to see what the current price is, but it will not be finalized until we actually get ready to release the order, then lock in a price with the vendor. So make sure you fill in the price. Finishes, the first 4 finishes on here are default finishes, the Aladyne, Anodize, black, and mill. The parts, the section that you guys need to fill out is your main paint color. Be sure to include the UC code and then the color name. And then typically the F finish type is reserved for anything that's fabricated and post-painted. You'll want to confirm the total pounds that you're ordering and make sure that it's equal to or less than what sales carried. If you have a big gap in sales and what your actual metal order is, you may want to do a little bit more research into it, especially if the pounds ordered is over the estimated pounds. I wanted to point out that the quantity in the over column is a pre-calculated number. So don't go adjusting that. Talk to purchasing first before you adjust those numbers. The stock lengths that are shown are determined by takeoff and the optimization requirements. So you should not have to change any of the lengths. And one thing that typically gets everybody is if you need to add a part because it was not included at takeoff, it was something that you discovered after takeoff was doing their process. You can't just go and insert a line. Each of these lines contains a lot of formulas. So the best thing to do is to go to the bottom of the spreadsheet, actually copy that blank line, and then go and insert it somewhere on your form, and then start filling it out. You'll want to make sure you fill out the quantity required. And like I said, if you put the quantity in the actual column, it will factor in the overage you need. Make sure you type out the part number correctly. It needs to have a dash in it. If you do not have a dash, if you do W755369 without a dash, it will not pull up the information regarding that profile. So you need to make sure that you include a dash in your number. Make sure you put in the length. And if for some reason you see information that comes over as no exist or NA, talk to purchasing and we can figure out what's going on with that profile. Okay. All right, next we'll go over what purchasing does once we receive the order from the project manager. When purchasing receives the metal order from the PM, there are additional steps that need to be taken before it can actually be released to the vendor. We confirm the metal price. If metal was not booked, purchasing will secure a metal contract with the extruder based upon the ordered pounds and the delivery date. We'll confirm the pricing for all finishes, struts, and we confirm that all setup charges for each extrusion and assembly have been accounted for. We then run a program on the Excel file that inserts the sub-assemblies or the A and the B parts for each assembly. We review all the profiles and adjust the finishes if applicable. Sometimes on the assemblies, initially that part is being called out as being painted but once we insert the subassemblies, the A part may not be exposed. It may be covered literally by a cover. So in that case, we'll change the A part to an allodyne finish. And then we'll have the B part be the painted part. We'll review all the other parts individually on the order to make sure there's no issues with the finish. We add several sections to the spreadsheet, the main section being if there's any finish only items that may be coming from, you know, coastal aluminum, some of your miscellaneous angles, tubes, channels, or if we are pulling anything from our inventory that we need to send to get painted. We generate other POs and shop work orders required. That includes 2 POs to coastal aluminum, one for the material that needs to get sent to paint, and then a separate one for just the mill finish items. A separate PO will also be generated for any fab and post-painted parts, such as your sunshade brackets. Also, that would include your hook lugs and bayonets as well. A shop work order will be sent to the shop to ship the material that needs to get painted. And then there's also, could be another work order to the shop to pull material that is available from other projects that are usually small run. Those will be mill finish or allodyne. We never send another project on the initial project order any painted material. So it's usually allodyne or mill finish items that we would pull from another project. We also take the door parts and enter that onto a forecasting spreadsheet so we know what is going to be cycling through our inventory. And a couple of other items I did not notice, when there are multiple due dates on an order, we divide the extrusions of the order based upon what is required first. If a job has a 10-week duration in the shop, for example, the first delivery will include not only all the small run parts, which is anything under 4,000 pounds, but it will also include strictly what is required for those first 5 weeks of fabrication. And then we'll have the balance of the material coming in like somewhere around week 3 of fabrication. Once the order is finalized, the order is sent to the vendor. On average, we will receive the acknowledgements around 4 to 5 days after the order is placed. Purchasing then double checks the acknowledgement against the order to confirm everything is correct, and then we update the report 3 with the due date and attach the acknowledgements. So I wanted to give you a little idea of what happens at the extruder once we release the order. The dies are scheduled at the press approximately 5 to 6 weeks prior to the order due date. Dies are then released to the press approximately 3 to 4 weeks prior to the due date. And whenever we tell you that the die is at press, that means it's been sent out and put in that hot box and staged to be extruded probably within the next 24 to 48 hours. Once the material is extruded, it is either sent to fabrication if needed or staged at the paint line. After paint, the material is either moved to the isobar or strut line if the parts are in assembly, or it goes to packing. Once all of the components for the assemblies are at the isobar line, the related parts are assembled together and then moved to packing. And then once packed complete, the bundles are staged for shipping. When the material is ready to ship from the extruder notifies purchasing to schedule the delivery with the shop. After the truck is unloaded at the shop, after the truck is loaded at the vendor, a packing slip is emailed to purchasing. When the material is received, shipping and receiving confirms that all the bundles per the packing slip are accounted for, and they note on the packing slip if there's any damage or if there's bundles missing, or if an extra bundle is received, and then they scan the packing slip so it gets emailed to the project manager and purchasing and links to the PO in the portal. Purchasing tracks the material received on a printed out copy of the material order form. When the material for a line item is received complete, the PO in the system is updated and with the actual quantities we receive. So if you ordered 50 pieces, the ship tolerance is 5 pieces. If we receive those full 5 pieces, then your PO will show 55 pieces as being received. When the order is received complete, the PO will be finalized and sent to the PM, notifying them that the order is received complete. And that PO has the most accurate information on it of what was received. I know we have some questions. Could somebody let me know what those are?
I will let you know.
Thank you, Jerry.
When purchasing splits up deliveries on larger projects, so we get the first 5 weeks worth of metal before we start, and then the balance during week 3 of fabrication, does the vendor extrude all the metal at once or hold it? Or do they extrude twice? If they extrude twice, we get dinged for double extrusion tolerances.
Yeah, so when we split it up, we take a look at that because we don't want to pay any additional setup charges. So that's why I stated that any of the small run items, which are 4,000 pounds or less, would be received in the first delivery. The reason for the 4,000 pounds is if you have 3,600 pounds, their minimum run requirement to avoid a setup charge is 2,000 pounds. So there would be another 1,600 pounds. Well, that's not enough to avoid a setup charge. So that's why we run anything under 4,000 pounds together and is delivered in that first delivery. The only time that we will get dinged a second time is on assembly parts. So if we have a job that has a horizontal and there's, let's say, 25,000 pounds of that horizontal, we only need probably half of that for the first 5 weeks of fabrication. So we will have 2 separate delivery time frames and get charged a setup charge for the assemblies, but that's more effective than having the shop sort through bundles and bundles of material. So that's why we're splitting it up, so the shop's not completely overwhelmed with having to move around material that's not needed. I hope that answers the question.
Yeah, it was more like if you had like 1,000 stock lengths, Heather, and if you got 500 of them up front, and then we receive 550 or whatever the tolerance, the extra tolerance is. Do you know that in time to update the second run and say we only need 450, or do you just order 500 twice and get 550 twice? That was more my question.
Okay, gotcha. So it depends upon how much time we have between the deliveries. If the deliveries are only a couple weeks apart, so I'm talking like 2 to 3 weeks apart, we may not have time to adjust. But once we bring the material, we receive the material and we see that we received a ship tolerance on that first shipment, we will try to adjust those subsequent shipments. We've been working with the extruder to try to get them to manage that on their side. We're not quite there yet. I keep on asking every so often, and we're just not quite there yet. So, but we do make an attempt to try to minimize that.
Cool, thanks.
All right. Anything else, Jerry?
Yeah, one other thing, please notify takeoff group for any new parts you are ordering or finish changes after it was released to PM. So just a heads up.
Yes.
That's it.
All right, cool. Well, we will continue on to paint, and I know we're restricted on time. So on finishes, the paint we use is a Kynar 500 based paint. It is a high performance fluoropolymer paint coating that meets AMA 2605 specifications. There are several paint manufacturers that provide paint that meet this specification, but the two we primarily use is PPG and Sherwin-Williams, formerly Valspar. There are several different formulations of paint we use that fall under the AMA 2605 specs. A two coat consists of a primer coat and a color coat. It can be a solid color, or the color coat can include a pearlescent mica flake, also known as Sunstorm or Classic 2. A three coat consists of a primer coat, color coat, and clear top coat. In the color coat, there is an aluminum flake in the paint, and the purpose of that clear coat is to protect the aluminum flake from oxidizing. And then there's a four coat. I think we've only had a four coat one time in the last 15 years, but it consists of a primer coat, a barrier coat, color coat, and a clear top coat. The four coats look similar in appearance to a three coat when it's a metallic, but they are more expensive, and it does have a different formulation of numbers for the code call out. So it's important to make sure when a vendor specifies a color that it's not a four coat. And we've had a few times where that's happened and have had to go back and let the customer know and obtain a three coat match. Whatever the finish is, you want to make sure that the customer let me start over there. Whatever the finish is, you want to make sure what the customer is wanting meets the project specifications and is also covered in our bid. Paint on extrusions is applied in a spray application. This process has more variability that can result in the inability to achieve perfectly random flake orientation. And that is why we can see variation not only between parts, but also within a stock length. It is difficult for paint to be applied on inside corners or recessed areas. It is important to point out these conditions to the vendor. Even though the exposed surfaces are shown on the die drawings, purchasing usually points out any inside corners or recessed areas when we release the metal order, just so the vendor can have the conversation with the paint line to pay attention to those areas. I wanted to point out to you the difference in coil coat paint application. This type of application is not available for extrusions. We see it on composite panels. The paint is applied on a continuous aluminum coil. In this application, the color and the flake consistency is better, is more easy to achieve due to the spray distance being at a constant, and it doesn't have a lot of varying surfaces. And a couple of ways you can help manage and minimize the risk of mica or metallic variation is by minimizing the number of applicators used to paint material on a project, and by having applicators match from a main production line sample and not the manufacturer paint chip. There is a Swiss for the PMs to follow for the finished sample procurement process. It's called Finished Sample Approval Swiss. Basically, once you know the colors for the project, you will request purchasing orders the manufacturer paint samples. Once they are approved by the customer, the PM will notify purchasing about the approval, and purchasing will start procuring production line samples. We start with the extruder, and once we receive the extruder production line samples, if there's panels on the project that match the extrusion, we will send the extrusion sample to the panel paint applicator and have them match off of that production line material. And then we will also have extra samples available for the PM to send out to any other vendors that are providing painted materials, so that they're matching to that production line sample and not to the manufacturer's paint chip. And then there'll also be extra samples available to give to the contractor for final submittal, and also if there's any other trades on the job needing to match our system. Let me see. Other finishes that you'll see are mill finish, which is plain aluminum with no finish. ANODIZE, this is a pre-treatment for paint, but we'll also use it for sealant adhesion. And typically you only order ANODIZE if it's in a non-exposed area. Anodizing. When you order ANODIZE, you need to specify the class required. For architectural applications, it's class 1. If we're using an application that's not exposed, we'll order a class 2. And standard colors available for architectural finishes are clear, champagne, light bronze, medium, bronze, and black. And if you guys have the opportunity to go back and view this presentation later, there are some links here to see of that ANODIZE process. Going into paint and ANODIZE warranties. For AMA 2605 paints, we can get a 10 or 20-year warranty. The warranty time period can be affected by hazardous environments such as coastal or industrial areas. Warranties are kind of finicky, but PPG's coastal distance requirement is 1 mile, and they require a 3-coat to obtain the 20-year warranty. Sherwin-Williams coastal distance is 1,500 feet. They will offer a 20-year warranty if less than that, but when we get the warranty, it will have special instructions for cleaning and maintenance. And then typically the warranty requirements vary by applicator, and Certified Enameling provides their own warranty, and their coastal distance is 5 miles, but they do honor our warranty requirements on the 2-coat paints. And warranties for ANODIZE class 1 is typically 5 years. There are viewing criteria when looking at architectural painted material. You can reference this in AMA 2605 section 5.2 that states coating shall be visibly free from flow lines, streaks, blisters, and other surface imperfections in the dry film state on exposed surfaces when observed at a distance of 3 meters, which is 10 feet, from the metal surface and inspected at an angle of 90 degrees to the surface. Other resources you can obtain off the wiki are cleaning and maintenance instructions. I wanted to show just a few causes for rejection. This first one here to the left, the gasket raceway and the die was not properly extruded. The die clogged. So we would reject that material and ask for replacements. In this middle picture here, there were rack marks on the exposed surface. So we would reject that. Down here at the bottom, there's like what they call die drag, where a chip got stuck in the extrusion and it created a gouge in the metal. Over here we have a variance in the paint colors between two parts, and the one is out of tolerance. And then on this one over here, the strut did not stay crimped and it fell off. So obviously it'd reject that material. And here's just a couple other pictures of some die drag or gouges in the painted product. Typically when there is rejection in the shop will notify the PM and purchasing, and we will go out and document what the damage is. And once we have a final piece count, we will request replacement material. And when we do request replacement material, we are credited back the material less the scrap value. So we are getting a full credit, but we're not seeing it fully credited against the PO because of the scrap. And this ends my presentation. I know there are some other questions, Jerry.
Jerry's gone.
Oh,
She had to
Lisa?
go to a meeting. I just wanted to know when you get the scrap value, where does that credit go back? It doesn't go back to the job, or?
No, it doesn't go back to the job. I don't know what they do with this check for the scrap when we scrap material.
Okay, probably just Walter's almost bottom line kind of thing.
Yeah. Yeah, and they use whatever our scrap rate is. Each extruder has their own scrap rate, but since we're scrapping it, they use what our local rate is, which I think currently is around 40 to 45 cents a pound. Were there any other questions on there?
I had one, Heather, on strut assembled parts. Do like which on a horizontal? I feel like I've heard sometimes the front part might slide a little bit in the shop. Is that a possibility, or is that not, I mean, I don't think it's supposed to happen.
Yeah, no, if the parts are moving, that should not happen. Right? That's there's a problem there, and I should be getting notified about that for replacements. But yeah, that should never happen. I know it has happened a couple times, but it was caught and we replaced the material right away. So yeah, that should not happen. If that's happening, they need to notify us. There's a process that the extruder goes through once they put the first piece through the strut machine. They have a set of jaws that take the A part and the B part, and they have a measuring tool that measures the force it takes to separate it. And then they check it I believe it's every 100 pieces that goes through the machine for that specific profile.
Cool, thank you.
Good job, Heather.
Anything else?
No, just good job.
Nice job.
Thanks, Heather.
See you.
Good job, Heather. Thank you.
All right, thank you. See you guys.
Thanks, Heather.
Yep.
You say goodbye. No, you say goodbye. You say goodbye. Bye,